Prepare to embark on a fascinating journey as we peel back the layers of the cosmos to reveal the majestic dance of celestial bodies. From stellar nurseries, birthing new stars, to awe-inspiring nebulae showcasing the beauty of cosmic destruction, we're about to traverse the frontiers of human knowledge. Stand on the edge of discovery and open your mind to the wonders of the universe that await. So fasten your seatbelts, space explorers, as we're about to venture into the extraordinary. Image 1. The Enigma of Pandora's Cluster. Deep in the heavenly expanse of the Sculptor constellation, a majestic site named Pandora's Cluster, or scientifically known as Abell 2744, resides. A massive ensemble of celestial bodies 3.5 billion light-years away. The spectacle of this galaxy cluster becomes even more intriguing as you delve into its mysteries. Peering through the universe's complexities, NASA's James Webb Space Telescope provides a unique window into the cosmos, capturing a captivating sight, bursting with around 50,000 beacons of near-infrared light. Imagine, if you can, this legion of light sources, each tracing its own unique journey across mind-boggling expanses of space to finally interact with the receptive instruments of Webb. The panorama they create is a visual testament to the enormity and diversity of our universe. Ever been overwhelmed by the convoluted web of paperwork and uncertainty that accompanies injury claims? Stress no more, as Morgan & Morgan has pioneered an innovation to simplify this intricate process, delivering straightforwardness and convenience right at your disposal. Welcome to a groundbreaking era in injury law, brought to you by Morgan & Morgan's 21st Century Law Firm. In less than 8 clicks, you can lodge an injury claim and have a legal professional examine your case. Say farewell to the days of navigating a complex web of legalities or being swamped in a deluge of documents. Their modernized system lets you track case particulars, endorse contracts, and upload pertinent documents and health records, all from your personal cell phone or laptop. For further details, visit forthepeople.com or dial #law. That's #529 from your cell phone. Stay cautious and allow the strength of Morgan & Morgan to accompany you on your legal endeavors. Now, let's continue with the video. Among these radiant celestial bodies, an eye-catching star, nestled towards the right side of the image, stands out. It's not from a distant corner of the universe, but instead a neighbor from our own galaxy, exhibiting Webb's unique diffraction spikes, a kind of radiant fingerprint that reveals the star's proximity to us. Among the stunning tableau of twinkling celestial bodies, Pandora's cluster is a standout. This massive formation of galaxy clusters, each one enormous in its own right, is gathering to form a colossal cosmic entity, a megacluster. Now, what makes this cluster of already huge galaxies so fascinating? The heart of the fascination lies in the incredible concentration of mass within this megacluster, so dense that it bends the very fabric of space-time itself, thanks to the force of gravity. This distortion creates a cosmic spectacle, a natural superpowered magnifying glass known as a gravitational lens. It allows us to perceive very distant, faint sources of light that would otherwise remain hidden from even the most advanced telescopes, including Webb. In the image provided by Webb, these far-off, lensed light sources appear as a ruddy glow, often stretched into elongated arcs due to the bending effect of the gravitational lens. Many of these are ancient galaxies, their internal workings amplified and stretched out, becoming an open book for astronomers to explore. Other red-hued sources await further analysis. Their true nature is yet to be determined. An intriguing point of interest is a diminutive red dot that stubbornly retains its compact form despite the magnifying power of the gravitational lens. Could it possibly be a supermassive black hole from the universe's infancy, hiding in plain sight? Data from Webb's near-infrared spectrograph instrument will soon tell us, providing distance measurements and the composition of these intriguing sources, offering a rich trove of previously unreachable knowledge about our universe's evolution. The tale of Pandora's cluster demonstrates the continuous, exciting journey of cosmic discovery that we, as a species, have embarked on. Each new discovery, each piece of the puzzle put into place, brings us closer to understanding our place in the grand scheme of the universe. And who knows, What we learn from this far-off cluster could unlock a new understanding of the cosmos as a whole. What other secrets do the stars hold, waiting for us to uncover? Number 2. Deciphering the cosmic riddles of NGC 1433. Let's set our sights on a cosmic marvel named NGC 1433, or PGC 13586, residing 46 million light-years away in the constellation Horologium, a barred spiral galaxy with a fascinating double ring structure. Its celestial beauty is as mesmerizing as the mysteries it holds. To decode these celestial secrets, we turn to Webb's mid-infrared instrument, a pioneering piece of technology that can capture intricate details of distant cosmic entities. It is through MIRI's discerning eye that we can behold an image of NGC 1433 with spectacular precision. Let's take a moment to understand the image's orientation. Think of compass arrows that you'd use on a hike. Here, we also have compass arrows, but they work a little differently. Unlike the familiar north and east on a ground map, the direction of the north and east in the sky, as seen from below, is inverted. It's akin to flipping a map of the ground, viewed from above, upside down. So, in our image of NGC 1433, the north and east compass arrows indicate the orientation of the galaxy relative to us on Earth. So, what is it that makes NGC 1433 such a compelling celestial body to explore? This galaxy stands out due to its unique structure, a barred spiral galaxy with not one, but 2 rings. Now, what does that mean? Picture a cosmic dance where stars, dust, and gas whirl around a central region, creating a spiral shape, much like a spinning Catherine wheel firework. Through the middle of this swirling mass, imagine a bar of stars. Encircling this bar, we have 2 distinct rings, thus the double ring structure. It's a cosmic arrangement as complex as it is fascinating. Could these rings provide astronomers with vital clues about the evolution of galaxies or star formation? Are there aspects of this galaxy yet to be uncovered that might further our understanding of our universe's grand tapestry? As we continue to probe the depths of NGC 1433, with advanced tools like MIRI, we hope to answer these questions and more. The study of NGC 1433 is a testament to humanity's thirst for knowledge, our need to understand the broader context of our existence. Every glimpse we catch, every fact we unveil about these distant cosmic wonders brings us one step closer to unraveling the enigmas of the universe, bringing the mysteries of the cosmos just a little bit closer to home. Image number 3. Piercing the veil of the dwarf galaxy. Wolf Landmark Milot. Set your cosmic compass to the constellation of Cetus and journey with us into the celestial wonder of the dwarf galaxy. Wolf Landmark Milot, or WLM for short. As one of our universe's humble residents, WLM is a barred, irregular dwarf galaxy, smaller than our own Milky Way, located approximately 3 million light-years from us. Despite its petite stature, it holds a vast universe of insights, if we can only unravel them. Images of WLM, captured by 2 phenomenal space instruments, the Spitzer Space Telescope and the James Webb Space Telescope, provide us with a window into this remote galaxy. They help to unfold the mysteries that lay within WLM, inviting us into a realm of astronomical discovery. Let's delve deeper into what these images represent. You might notice that the images are different colors. This isn't an artistic choice, but a practical one. Each color represents different wavelengths of light captured by the telescope's cameras. So, what does that mean? Well, light that we can see is just a small part of a broader spectrum, ranging from very short gamma rays to very long radio waves. Infrared light sits just beyond the red end of the visible spectrum and is longer than red light. It's the type of light that's emitted by anything that has heat, even objects that don't seem hot to us, like ice cubes. The Spitzer image shows 3.6 micron light. A micron is 1/millionth of a meter in cyan, and 4.5 micron light in orange. Here the term micron refers to the light wavelength. Smaller numbers mean shorter wavelengths, which equate to higher energies. On the other hand, the James Webb Space Telescope's image of WOM showcases its prowess in resolving faint stars beyond the Milky Way. It features 0.9 micron light in blue, 1.5 micron light in cyan, 2.5 micron light in yellow, and 4.3 micron light in red. But why is this important? Well, by looking at different wavelengths of light, we can discern various details about WLM. Certain wavelengths might highlight areas of star formation, others the presence of certain elements or dust. Each color brings a new layer of understanding to the celestial body in question, allowing us to dissect WLM's composition, behavior, and history in ways that would otherwise be impossible. Our exploration of WLM takes us into a field of view that is approximately 2 arc-minutes across. That's roughly 1,700 light-years. Imagine the sheer number of stars, planets, and celestial phenomena within this vast expanse. What might they tell us about the universe we inhabit? The detailed study of galaxies like WLM helps us piece together the larger cosmic puzzle. Each revelation adds to our understanding of the universe and how it works, encouraging us to ponder what other galaxies, stars, and cosmic events lie in the universe's expanse, awaiting our discovery. Every small dwarf galaxy we study might just hold the key to unlocking the universe's next big secret. Number 4. The cosmic drama of MAX 0647. Imagine a spectacle where celestial entities, vast distances, and the fabric of the universe itself come together to reveal a grand cosmic drama. Welcome to the narrative of the galaxy cluster, MAX 0647, and the remote system, MAX 0647JD, located in the constellation Camelopardalis. MAX 0647 is a galaxy cluster that's an impressive 5.6 billion light-years away from us. That's a distance so immense, light from it takes billions of years to reach us. To make this number relatable, if we were to travel at the speed of light, it would take us 5.6 billion years to reach MAX 0647 from Earth. And yet, with our telescopes, we can reach out and study it from our own cosmic neighborhood. One of the most intriguing aspects of MAX 0647 is its gravitational field, so immense that it bends and amplifies the light from more distant galaxies, acting like a cosmic lens. This cosmic lensing is so powerful that it causes the image of the distant system, MAX 0647JD, located even further away at an astounding 13.3 billion light-years, to appear in 3 different places. Just like a hall of mirrors, this tripling effect creates 3 images of MAX 0647JD, designated as JD1, JD2, and JD3. These unique triply lensed images, captured by the James Webb Space Telescope's near-infrared camera, NIRCam, instrument, offer us a glimpse of the past. You see, the light we observe from MAX 0647JD has traveled over 13 billion years to reach us, so we're seeing the galaxy as it was when the universe was just a fraction of its current age. Isn't that mind-boggling? Let's decode the color scheme of the NIRCam image. Different colors are assigned to various light wavelengths. Blue represents wavelengths of 1.15 and 1.5 microns. Green denotes 2.0 and 2.77 microns. And red corresponds to 3.65 and 4.44 microns. As you may recall, a micron is a millionth of a meter, and different wavelengths of light can reveal different features of celestial objects. In a sense, we're looking at MAX 0647 and MAX 0647JD through a cosmic prism that reveals the various aspects of their makeup. The study of MAX 0647 and MAX 0647JD provides a unique glimpse into the nature and evolution of galaxies. What secrets do these distant systems hold? What can they tell us about the universe at the time they emitted the light we're now seeing? And perhaps most importantly, what other hidden wonders might be revealed through the lens of powerful galaxy clusters like MAX 0647? As we continue to probe the cosmos, we are sure to uncover more about our mysterious and captivating universe. Number 5. The spectacular final act of a star. Let's embark on a journey through the cosmos to the constellation of Gemini, also known as the Twins. Hidden within this celestial region, we find a rather mysterious spectacle. The remnants of a once vibrant star, now spread across the cosmic stage in an intricate display of its final act. This celestial object, also known as NGC 2371, tells a fascinating story of a star's life and death. At first glance, NGC 2371 puzzled the early sky gazers who recorded it as two separate objects due to its symmetrical structure, leading to it also being known as NGC 2371-2. Resembling two giant cosmic bubbles, these lobes occupy the upper right and lower left parts of the frame, and together create what is known as a planetary nebula. Though the term planetary nebula might lead you to think of planets, it's a bit of a cosmic misnomer. This name originated from the planet-like round shape of these nebulae when observed through early telescopes. In reality, a planetary nebula like NGC 2371-2 has a much more celestial origin. It's the last hurrah of a sun-like star at the end of its life. Imagine a star similar to our sun, exhausting its nuclear fuel after billions of years. Unable to sustain the heat and pressure at its core, the star expands and then expels its outer layers, catapulting stellar material into the surrounding space. What remains is a superheated remnant, a core glowing with intense heat, visible in this image as the vibrant orange-tinted star neatly nestled between the two lobes. NGC 2371-2 is far from a static picture. It's a bustling and complex cosmic construction site. It's filled with dense gas clumps, zippy jets seemingly changing their course over time, and expanding clouds of stellar material being pushed out on completely opposite sides of the remnant star. Some patches of this astronomical tableau radiate with a bright glow, energized by the radiation from the remnant star that stirs up the gas within these regions, igniting it with radiant light. What lies ahead for NGC 2371 halves? Over the next few thousand years, this cosmic spectacle will continue to evolve. The dense lobes will eventually dissolve completely, scattering their contents across the cosmos. The remnant star will cool and dim, transitioning into a white dwarf, a dense stellar core that no longer produces nuclear energy. In witnessing the grand spectacle of NGC 2371-2, we see a vivid illustration of the life cycle of stars. Isn't it astonishing to think about the forces and processes that shape our universe, from the birth to the death of a star? As we unravel the mysteries of such celestial phenomena, we gather profound insights about our cosmos and our place within it. Number 6. When new stars illuminate history. Welcome to a cosmic scene set within an intriguing star-forming region known as N90. What makes this astronomical setting unique? It's bustling with newly born luminous blue stars, their vibrant glow carving a cavity in the heart of N90. Nestled in the vast constellation of Hydrus, about 200,000 light-years from us, N90 is quite the celestial artist, painting a unique portrait of star birth and evolution. The new stars, much like enthusiastic youngsters, are dynamic and full of energy. They radiate high-energy light that interacts with the nebula surrounding them, gradually eroding it from the inside out. Imagine a sandcastle being gently worn away by the incoming tide. That's what the young stars are doing to the nebula. They're sculpting it, gradually chiseling away the outer portions. The nebula, though, doesn't let this energy escape so easily. Its diffuse, hazy outer regions act as a barrier, trapping the energetic outflows and preventing them from streaming away directly. This intense interaction creates a unique, ever-changing cosmic landscape. What adds to the grandeur of this scene is its setting. Because N90 is far from the central body of the small Magellanic Cloud, a galaxy nearby our own Milky Way, the backdrop of the image is adorned with countless distant galaxies. It's like looking at a theater stage where new stars are the main actors and countless galaxies form the audience. But wait, there's more. The dust within the N90 region has a special role to play. It acts as a cosmic filter, giving the galaxies in the backdrop a reddish-brown hue. This coloration isn't just visually captivating. It also offers clues about the properties of the intervening dust and gas. The sight of these vibrant blue stars coming to life in a region like N90 offers a glimpse into the process of star formation. It leaves us with fascinating questions. How do such stellar nurseries shape the evolution of galaxies? What role do these new stars play in the transformation of the nebulae from which they were born? And as we learn more about these stellar newcomers, what other cosmic secrets might they reveal? With every celestial object we study, we learn more about the complex processes that govern our incredible universe. Image 7. The mysterious shadow of HBC 672 in the Serpens Nebula. Enter the world of the Serpens Nebula, a cosmic cradle where stars are born, nestled some 1,300 light-years from our home planet. This celestial nursery, found in the constellation of Serpens Cauda, the serpent's tail, is a complex web of gas and dust. As we delve into this nebula, a strange spectacle unfolds. A shadow, colossal in its proportions, is being cast by a protoplanetary disk surrounding a star known as HBC 672. The disk, packed with debris and the building blocks of planets, is remarkably tiny on cosmic scales, far too small to be seen even with the powerful capabilities of the James Webb Space Telescope. So how can we witness its existence, you might ask? Much like a small bird can cast a noticeable shadow on a bright sunny day, this disk projects a mammoth shadow on the cloud from which it was birthed. This sight is so distinctive that it has earned a nickname, the Bat Shadow, due to its shape reminiscent of a bat's spread wings. Here's an intriguing fact. This bat shadow sprawls about 200 times the diameter of our solar system. Imagine 200 solar systems laid end to end, and that's the extent of this cosmic shadow. Its grandeur isn't just fascinating, it's also crucial for astronomers as it offers insights into the shape and size of the hidden disk that is casting it. Now shift your gaze to the upper left of the image. Do you see that similar shadowy figure emerging from another young star? It seems as if the cosmic shadows are not uncommon in this bustling stellar nursery. Each shadow tells a unique story of the hidden disks, shaping our understanding of star and planet formation. These intriguing shadows spark questions. What kind of worlds might eventually form from the disks casting these shadows? What can these shadows tell us about the early stages of planetary formation? How do the size and shape of the shadows correlate with the properties of their disk origin? With every shadow we observe, we are a step closer to unraveling the captivating story of star birth and planetary evolution. Number 8. Cassiopeia A. The intricate portrait of a star's final act. Gaze into the cosmos, about 11,000 light-years from our earthly home, and you'll find Cassiopeia A, or Cas A, as it's fondly known among astronomers. What's unique about this celestial object, you may ask? This isn't just any patch of the sky, but the youngest known supernova remnant in our Milky Way galaxy. If you're wondering what a supernova is, think of it as a star's grand finale, a powerful explosion marking the end of a star's life cycle. The new image, captured by the James Webb Space Telescope, uncovers the compelling complexity of Cas A. It reveals a complex jigsaw of shattered star fragments, an intricate mosaic of cosmic debris strewn about in the aftermath of a star's violent death. It's as if we're looking at the detailed crime scene of a stellar explosion, piecing together clues of a celestial puzzle. Residing in the constellation of Cassiopeia, the famed W or M-shaped pattern in the night sky, Cas A is not only a spectacle for its beauty, but also for the wealth of knowledge it holds. This supernova remnant offers astronomers a unique window into the life and death of a star. Here's something to ponder over. Each fragment captured in this image was once part of a star much like our Sun. What events led to such a dramatic end? How does this intricate pattern of fragments relate to the star that once was? The answers to these questions hold the secrets of stellar evolution, secrets that we are just beginning to uncover. Understanding supernova remnants, like Cas A, is crucial for our knowledge of the cosmos. They play a key role in the cosmic cycle of matter, recycling heavy elements forged within the star back into the interstellar medium, the raw material for new stars, planets, and possibly even life. Through its kaleidoscope of colors and patterns, Cas A serves as a poignant reminder of the transience of stars, yet also of their enduring legacy, as the elements they scatter play a crucial part in creating new celestial bodies. In its destruction, a star thus sows the seeds for new celestial life, and in studying these remnants, we step closer to understanding the intricate tapestry of the cosmos. Image number 9. Taurus's cosmic ballet. Of jets, bubbles, and brilliant illuminations, amidst the inky black cosmos, approximately 450 light-years away from us, lies a captivating spectacle, a multiple star system known as XZ Tauri, nested within the constellation of Taurus, the Bull. But this cosmic stage doesn't only host the stars, it's an arena for an entrancing celestial performance that leaves even seasoned astronomers marveling at its complexity. What's so special about this place in the cosmos? One might wonder. To start, XZ Tauri isn't a regular star system. Rather, it's a hotbed of activity. A cosmic nursery, if you will, bustling with stellar infancy and adolescence. Here, stars are not just twinkling specks of light, but dynamic entities, emitting powerful winds and jets that carve their surroundings. Imagine XZ Tauri as a powerful celestial entity, exhaling a hot bubble of gas into the void around it. This bubble, not like the ones children blow on a sunny afternoon, is of gargantuan proportions and extreme temperatures. This hot bubble permeates the space around XZ Tauri, interacting with the interstellar medium, the cosmic soup that fills the spaces between the stars. This region is also the stage for a spectacle of illumination, akin to the grandeur of fireworks. A collection of bright, beautiful clumps nearby, young stellar objects, YSOs to be precise, light up the vicinity with their strong winds and jets. YSOs, as their name suggests, are stars in their early stages of evolution, not unlike toddlers learning to walk. How do we imagine this scene? It's a bit like a cosmic ballet, with jets of material shooting out from young stars and bubbles of gas expanding, while bursts of light illuminate the otherwise dark theater of the universe. This cosmic neighborhood also includes HL Tauri, another star system similar to XZ Tauri. Together, they form a bustling stellar community, a vibrant testament to the continuous cycle of star birth, evolution, and death. The question to ponder is, what forces propel these winds and jets? What fuels these brilliant illuminations that bathe the region in a celestial glow? These are the mysteries that astronomers seek to unravel when they gaze into regions like XZ Tauri. Through understanding star systems like XZ Tauri and HL Tauri, we draw a clearer picture of our galaxy's life story, unraveling the processes that ultimately led to the formation of our own solar system, and perhaps life on Earth itself. Number 10. The Celestial Championship, NGC 1333's stellar lineup. In a bustling galactic city where roughly 300 billion stars dwell, our James Webb Space Telescope has managed to isolate and highlight just a small team of stars, all huddled together under the banner of NGC 1333. Imagine, if you will, a sports team where each member is a brilliant star, and their home ground is a colossal cloud of gas and dust. This extraordinary celestial team comes together to form a tableau that's nothing short of a spectacle. So where is this team performing its celestial plays? NGC 1333, their cosmic stadium, is nestled approximately 1,000 light-years away within the constellation of Perseus, named after the legendary Greek hero. This arena is more than just a gathering spot for stars. It's a star-forming factory where cool gas and dust come together to form new stars. But what does this birth process entail? As a new star comes into being, its intense light reflects off the surrounding gas and dust. This scattering of starlight illuminates the otherwise dark nebula, broadcasting the existence of NGC 1333 to telescopes like Webb, positioned billions of miles away. This phenomenon gives NGC 1333 its specific classification as a reflection nebula. The image captured by Webb, however, only presents us with a singular vista within the vast territory of NGC 1333. It's akin to seeing a close-up of a few football players on the field, while being unaware of the entire team spread out across the pitch. Yet Webb's extensive imaging of this region reveals that this cluster of stars is not alone. There are many such clusters within NGC 1333, all part of this cosmic championship, each playing out their roles in the grand scheme of star birth and evolution. This scenario leads to intriguing questions. What happens when these stellar teams collide? How do the birth and evolution of stars impact the nebula they call home? The ongoing study of NGC 1333 and similar regions helps astronomers understand the answers to these questions, bringing us one step closer to unraveling the mysteries of our Milky Way. In the vastness of the universe, NGC 1333 serves as a constant reminder of the cosmic ballet being played out across the galaxies, an ongoing championship of star formation, evolution, and ultimate demise. Image 11, a spotlight on Orion's lesser-known prodigy, Messier 43. Nestled in the cosmic neighborhood of Orion, there lies an understudied nebula that has managed to remain somewhat obscure despite its proximity to one of the sky's most famous regions. This celestial underdog is known as Messier 43, or in honor of its discoverer, de Mairan's Nebula. Sharing the stage with its renowned sibling, the Orion Nebula, Messier 42. Messier 43 is divided by a mere dusty pathway that separates the two stellar siblings. Both Messier 42 and Messier 43 are integral components of the colossal star-forming region known as the Orion Molecular Cloud Complex. This complex, akin to a cosmic nursery, fosters the birth of stars and includes other illustrious members like the Horsehead Nebula, Barnard 33, and the Flame Nebula, NGC 2024. Each of these celestial bodies contributes to the complex's vibrant tapestry of star formation. Positioned approximately 1,400 light-years away from Earth, the Orion Molecular Cloud Complex is one of the nearest regions to us where stars are actively being born. This proximity has offered our James Webb Space Telescope a front-row seat to the spectacular theater of stellar birth and evolution for the past 2 decades. What exactly has Webb been observing in this region? It has been meticulously tracking how winds, emitted from young, energetic stars, carve intricate shapes into the gas clouds. It has also been studying the newborn stars themselves and their immediate surroundings, and even discovering hidden gems like brown dwarfs. These are objects that are larger than planets but not quite full-fledged stars. The image of Messier 43 captured by Webb brings into focus several of these radiant, youthful stars. It also uncovers many intriguing features around stars that are still in their infancy, swaddled within a cocoon of dust. Despite their initial obscurity, these features are now highlighted, shedding light on the process of stellar birth and growth. Number 12. Unveiling the mysteries of the Lagoon Nebula through infrared vision. Gaze upon the infrared majesty of the Lagoon Nebula, a celestial spectacle that is more than it initially appears. This nebula, with its kaleidoscope of hues, offers an intriguing glimpse into the mysteries of the cosmos. Have you ever wondered what makes an infrared image different from a visible one? Let's journey into this fascinating contrast. In an infrared image of the Lagoon Nebula, one of the most striking distinctions is the sheer number of stars that fill the frame. Some of these stars are distant, located far behind the nebula, while others are newborn stars residing within the Lagoon Nebula itself. The Lagoon Nebula, lying between 4,000 to 6,000 light-years away from our planet, presents a spectacular sight in our night sky. Spanning an angular size of 90 by 40 arcminutes, this translates to a real size of 110 by 50 light-years across. It's easy to get lost in the scale of these measurements, but imagine it like this. Traveling at the speed of light, it would take you 110 years to traverse its width. When observed through binoculars or a telescope, the nebula exhibits a gray tone due to the human eye's low sensitivity to color at dim light levels. But when captured in time exposure color photos, the nebula blooms into a mesmerizing pink hue. Interestingly, the Lagoon Nebula is home to a number of Bok globules. Now, what are these? Bok globules are dark, compact clouds of cosmic dust and gas that collapse under their own gravitational pull, birthing new stars. The most notable among them in the Lagoon Nebula are cataloged by E. Barnard as B88, B89, and B296. One particularly eye-catching feature within the nebula is a structure resembling a funnel or tornado, brought about by a hot O-type star. This star emits ultraviolet light, which in turn heats and ionizes gases on the nebula's surface. Additionally, nestled within the heart of the Lagoon Nebula is a formation known as the Hourglass Nebula. Don't mix it up with the more famous engraved Hourglass Nebula found in the constellation Musca. Named by John Herschel, this Hourglass Nebula in 2006 was found to host 4 Herbig-Haro objects, bright patches of nebulosity associated with newborn stars. This discovery provided compelling evidence of active star formation happening right in its heart. The Lagoon Nebula is nestled in the constellation of Sagittarius, serving as a beacon of active star formation in our Milky Way. As we delve deeper into the mysteries of the Lagoon Nebula, we realize that this cosmic lagoon is more than just a picturesque scene. It's a thriving stellar nursery, a beacon of light in the dark cosmos, and a fascinating subject of study for astronomers. What other secrets does the Lagoon Nebula hold? Only time and continued exploration will tell. Number 13. The Cosmic Farewell of PK 329022. Say hello to the cosmic phenomenon known as PK 329022, a planetary nebula located in the southern constellation of Norma. This celestial object also goes by another name, Menzel 2 or Maz 2, a nod to Donald Menzel, the astronomer who first identified this nebula in 1922. Have you ever wondered what happens when stars, similar to our own sun, reach the twilight of their existence? They don't just fizzle out quietly. Instead, they cast off their outer layers into the cosmos. These expelled layers manifest as glowing clouds of gas that we recognize as planetary nebulae. But why are they called planetary? It's a bit of a historical misnomer, as they were named by early astronomers who, when looking through their rudimentary telescopes, mistook these objects for planets. As stars bid their final adieu, the manner in which they eject their mass isn't a tidy process. It's irregular and lacks symmetry, leading to the creation of planetary nebulae with intricate, often captivating shapes. In the case of Menzel 2, the nebula forms a serpentine-like blue cloud that seems to twist and twirl around two central stars. Back in 1999, astronomers made an interesting discovery. They found that the star situated towards the upper right is actually the heart of the nebula itself. The star located to the lower left, on the other hand, is likely a true companion to the central star. Just imagine two stars bound together in their cosmic journey amidst the backdrop of a stunning nebula. This gaseous envelope continues to envelop the stellar core for tens of thousands of years. Then, over a span of a few thousand years, these vibrant clouds of gas slowly fade, dissolving into the vast cosmic sea. The curved structure of Menzel 2 seems to resemble a wave, a cosmic farewell, if you will, before the star transitions to its final stage of existence as a white dwarf. This intricate process provides a tantalizing glimpse into the life cycle of stars, even as they approach their end. PK 329022, or Menzel 2, is more than just a planetary nebula. It's a testament to the cosmic ballet of stellar evolution, unfolding over millennia in the grand theater of our Milky Way galaxy. As we continue to study these phenomena, what other intriguing details might we uncover about the life and death of stars? Number 14. Westerland 2, a celestial nursery in the heart of the Milky Way. Tucked away in the constellation Carina, some 20,000 light-years from us, lies an astronomical marvel named Westerland 2, a colossal gathering of approximately 3,000 stars. This celestial wonder paints an awe-inspiring portrait of stellar grandeur. Westerland 2 is not just an ordinary cluster of stars, but is classified as a compact young star cluster. In fact, some astronomers even propose that it could be a superstar cluster. But what does this mean? Simply put, it refers to a tightly packed cluster, teeming with young stars. Westerland 2, with an estimated age of just 1 or 2 million years, incredibly youthful in cosmic terms, perfectly fits this description. This cluster is not merely a cosmic spectacle, but a treasure trove for astronomers. It hosts some of the most scorching, radiant, and gargantuan stars known to us. Westerland 2 finds its home in a star-forming region named GUM 29, itself a bustling nursery of stars located in the far reaches of the Milky Way. In this cluster, you'll find a fascinating array of stars. Among them are at least a dozen early O stars, with 3 known to be eclipsing binaries. Without delving too deep into astronomical jargon, early O stars are just massive stars with incredibly hot surfaces, while eclipsing binaries are pairs of stars that orbit each other, periodically blocking each other's light as seen from Earth. Each of these O stars is hotter than 38,000 Kelvin and shines with a luminosity over 230,000 times that of our Sun. A unique feature of Westerland 2 is its population of Wolf-Rayet stars, which are extremely massive stars that have reached an advanced stage of stellar evolution. They are renowned for their strong stellar winds, which are streams of charged particles they emit into space. Westerland too houses several of these rare celestial gems, including WR20A, a binary system composed of two Wolf-Rayet stars, and the standalone stars WR20AA, WR20B, and WR20C. Each of these stars represents an example of the most luminous stars in our galaxy. In addition to these celestial titans, Westerland 2 also fosters a large number of pre-main sequence stars. These are stars that haven't yet started the primary phase of their life when they burn hydrogen to produce helium. Their presence provides valuable clues about the age of Westerland 2, which is estimated to be around 2 million years. As we delve deeper into the secrets held by Westerland 2, it's essential to remember that this star cluster isn't just an isolated formation. It's a part of our Milky Way galaxy, a small piece of the grand cosmic puzzle. By studying clusters like Westerland 2, we inch closer to understanding the life and evolution of stars, and ultimately, the workings of the universe itself. So what other secrets does Westerland 2 hold? Only time and more research will tell. Image number 15. The Crab Nebula, a cosmic lighthouse in the heart of Taurus. Peering into the depths of space, our gaze lands on the mesmerizing spectacle of the Crab Nebula, a cosmic marvel lying 6,500 light-years away in the constellation Taurus. While numerous images and research have focused on the intricate latticework of glowing filaments that form the nebula's outer layers, let's shift our focus inward, towards the enigmatic core of this celestial wonder. Nestled within this complex web of interstellar gas and dust, we find the central neutron star of the Crab Nebula. It is the rightmost luminary of the two bright stars near the center of many images, pulsating with a steady rhythm. This celestial beacon's rapid material motion creates a subtle spectrum of colors, almost like a distant cosmic rainbow. This rainbow effect arises from the continuous movement of material during the time between successive images, making for a breathtaking visual display. But what is the Crab Nebula exactly? Well, it's a supernova remnant, the remains of a once mighty star that ended its life in a cataclysmic explosion. It's also a pulsar wind nebula, meaning it's shaped by the powerful winds of radiation streaming from a pulsar, a rapidly rotating neutron star. This distinctive form inspired its common name, given by William Parsons, the 3rd Earl of Rosse, who likened its appearance to a crab. The Crab Nebula has a rich history dating back to 1731, when it was first discovered by English astronomer John Bevis. Interestingly, the nebula's presence corresponds with records of a bright guest star noticed by Chinese astronomers in 1054, providing evidence that this object is the relic of a supernova explosion witnessed almost 1,000 years ago. While the Crab Nebula's apparent magnitude of 8.4 isn't bright enough for naked eye viewing, under favorable conditions, you can spot it using binoculars. It resides in the Perseus arm of our galaxy, the Milky Way, and is continuously expanding at an astonishing rate of about 1,500 kilometers per second, almost 0.5% the speed of light. The nebula's heart houses the Crab Pulsar, an ultra-dense neutron star roughly 30 kilometers across. This star rotates a dizzying 30.2 times per second, emitting pulses of radiation that range from gamma rays to radio waves. This intense radiation makes the Crab Nebula one of the brightest persistent gamma-ray sources in the sky, especially at energy levels above 30 kilo-electron volts. What makes the Crab Nebula so special? Its radiation has been invaluable for studying celestial bodies that pass in front of it, known as occulting the nebula. For instance, in the 1950s and 1960s, scientists used the nebula's radio waves to map the sun's corona. More recently, in 2003, they gauged the thickness of Saturn's moon Titan's atmosphere using the nebula's X-rays. In the 1960s, the nebula again became a center of attention when Franco Pacini predicted the existence of the Crab Pulsar. The subsequent discovery of the pulsar, with the knowledge of its exact age, has since allowed astronomers to verify the basic properties and dynamics of these exotic objects, greatly contributing to our understanding of pulsars and supernova remnants. The Crab Nebula is not just an ordinary nebula, It serves as a testament to a stellar explosion witnessed across centuries and civilizations, a time capsule preserving key insights into the life cycles of stars. It's a cosmic lighthouse, with its pulsar heart emitting a steady beacon of radiation. In the field of high-energy gamma rays, it's a trailblazer, having been the first confirmed source of very high-energy gamma rays above 100 giga-electron volts. In 2019, the Crab Nebula made headlines again, observed to emit gamma rays exceeding 100 tera-electron volts, thus becoming the first identified source beyond this energy level. As we continue to unravel the mysteries of the Crab Nebula, one can only wonder, what other secrets does this cosmic wonder hold? Only the future of cosmic exploration will tell. 16. N159. Stellar nursery in the distant Large Magellanic Cloud. Far beyond the confines of our Milky Way galaxy, some 170,000 light-years from us, there lies a celestial marvel named N159. This isn't just any ordinary nebula, but an incubator of new stars, located within our cosmic neighbor, the Large Magellanic Cloud, LMC. And it is here, in this cosmic maternity ward, that a spectacular drama of stellar birth is unfolding. N159 is a massive nebula, with a breadth extending over 150 light-years. It's part of the constellation Dorado, which derives its name from the Portuguese word for golden. Quite fittingly, this golden constellation is home to N159, a dazzling spectacle that truly is a goldmine for astronomers. Now let's delve into what makes N159 so intriguing. This nebula is known for the intense stellar winds that ripple through it, winds generated by the newborn heavy stars within its folds. Have you ever seen the mesmerizing patterns winds create on a sandy beach, or the intricate ripples they etch on a still pond? The stellar winds in N159 are no different. They shape the nebula's gas and dust into ridges, arcs, and filaments, sculpting a breathtaking cosmic tableau. Think of these stellar winds as celestial artists, carving out the vast canvas of N159. But what's causing these winds? Well, the answer lies with the hot newborn stars within the nebula. These stars, much larger than our Sun, are born with so much energy that they emit powerful streams of charged particles, creating these stellar winds. The LMC, where N159 resides, is not just any galaxy. It's what astronomers call a satellite galaxy of the Milky Way, essentially a smaller galaxy that orbits our own. The LMC is a treasure trove of such star-forming regions, giving us invaluable insights into the processes that lead to the birth of new stars. Understanding the phenomenon taking place in N159 is no easy task. It requires us to venture far beyond the frontiers of our own galaxy and study processes that occur on a scale that's almost unimaginable. However, every piece of the puzzle we unravel brings us one step closer to understanding the mysteries of the universe. It leaves us to wonder, what else is out there, waiting to be discovered, in the vast expanse of the cosmos? Only time and the relentless pursuit of knowledge will tell. Image number 17, R136, a dazzling star cluster in the 30 Doradus Nebula. Imagine an expansive tableau in the far reaches of space, where countless stars emerge from a cradle of gas and dust. This cosmic panorama, known as the 30 Doradus Nebula, is not just a breathtaking spectacle, but a celestial nursery where thousands of stars are currently being born. And at the heart of this fertile region lies the star cluster R136, an astonishing assembly of massive stars that stands as the most spectacular of its kind in our local group of approximately 25 galaxies. Positioned a staggering 170,000 light-years away in the constellation Dorado, R136, appearing as a large, radiant blue cluster slightly to the left of the nebula's center, illuminates the region with a brilliance that is nothing short of spellbinding. But what is the story behind this luminous spectacle? R136 isn't just about the bright, shiny stars we see. There's a riveting interplay of creation and destruction going on here, making this cluster more than meets the eye. The stars within R136 are incredibly active, releasing potent ultraviolet radiation and ejecting high-speed material into the surrounding nebula. So how does this celestial drama unfold? The ultraviolet radiation and swiftly moving matter from the stars interact with the surrounding gas and dust, triggering an intricate cycle of creation and destruction. The radiation and the fast-moving stellar matter exert pressure on the surrounding gas and dust clouds, causing them to collapse. This collapse, however, is a creative one, giving birth to intriguing, pillar-like structures. But what's so special about these pillars? These pillars are not just aesthetic wonders in this grand celestial tableau. They are, in fact, cosmic incubators where new stars are taking shape. So, in essence, what we are witnessing in R136 is an ongoing saga of stellar birth, an intimate glimpse into the life-giving processes of the universe. This vibrant interplay between the stars of R136 and the 30 Doradus Nebula is a testament to the dynamic nature of our universe. It is a reminder that celestial bodies, no matter how far they might seem, are part of an interconnected cosmic tapestry, each playing a role in the grand scheme of the cosmos. The tale of R136 invites us to ponder, what other captivating stories are awaiting discovery in our universe's vast expanse? And there we have it, fellow voyagers, another breathtaking exploration across the cosmic canvas. Each celestial marvel we've witnessed today tells a unique story, painting a vibrant picture of our wondrous universe. Now it's over to you. Which cosmic spectacle captured your imagination the most, and why? Share your thoughts in the comments below. We're eager to hear your perspectives. If you enjoyed this journey among the stars, please show your support by liking this video and subscribing to our channel. Your engagement truly fuels our voyage and helps us bring more stellar content to you. The cosmos is vast and filled with many more mysteries waiting to be unveiled. If you're ready for another space adventure, click on the video on your screen now. Let's continue our exploration together, forging our path through the wonders of the universe. Safe travels, cosmic explorers.